speaker today. Dan Macpherson is going to present to us on surviving the robot apocalypse. And it's how technical writers can and should embrace automation in their work. So please make Dan feel welcome, everyone.
Okay, greetings everybody. Last presentation for the day, so let's get this out of the way so we can all go back to our hotel rooms and open the minibar. Surviving the robot apocalypse, how technical writers can and should embrace automation and AI. I also added post submitting this as well. And there's a bit of a distinction to be made, which I'll get into in the first slide. So just a bit of a definition here. How do I define robot apocalypse in the context of this talk? And how I define it is the relationship between technical writers and also other professions, other occupations, and automation and AI. Now, there's a distinction to be made between automation and AI. Automation is the ability for machines to accomplish a task, and AI is the ability for machines to make decisions. But both fall under the category of robot apocalypse because they both inspire fear among the general populace. Because when you hear the phrase automation and when you hear AI, a lot of people immediately turn to the negative perception of automation. So, for example, machines automate jobs, we start complaining, they took our jobs, and then the robot apocalypse uprising and humanity gets wiped out. So that's one perception of automation and AI. This is my perception of automation and AI. Pretty much the Futurama version. We have Fry and Bender, essentially best friends, and that middle picture there, I think, pretty much sums up how I feel about automation and AI, where we're pretty much embracing AI and automation. Now, the big question, will robots eventually replace all tech writers? No. End of talk. Thank you very much, everybody. There's a bit more to that as well. A lot of people tend to think that with a lot of jobs, automation will replace their jobs. And I don't think so for tech writers, mainly for this reason. You have two different scenarios here. So scenario one, what most technical writers think will happen. Hey, robot, go write the docs. And the robot goes affirmative and goes and writes the docs. This was actually a bit of a debate when I first joined Red Hat 9 years ago. We had two groups of people on IRC basically debating this exact topic. Will robots pretty much just replace tech writers and write the docs? The other side was sort of debating more from an ethical perspective, whether that should be the case. Now I look back on that debate, and I sort of think to myself, both sides are wrong, because when you think about it, I mean, getting robots to write the docs, it seems like a waste of a robot's time, because you have scenario two. Hey, robot, instead of writing the docs, go do the actual task. And the robot says, yeah, that actually sounds like a better use of my time. Makes sense? Possibly. And this is what I think should be happening, is focusing the robots not on content for humans to go, because we don't want to do manual tasks. Let's put the bots to work. Now you might be thinking, wait, that sounds worse. I mean, will we even need docs in the future? That still means that we're out of the job, right? Well, no, not quite. We're in a different way. We're still going to need docs. Because even robots need instructions. Wait, how do I install a database server? So in addition to writing docs for humans, we must consider writing docs for robots. So the main questions for this session: what's the current state of the robot apocalypse, the relationship between tech writers and machines and AI and automation? What opportunities are there for technical writers in the robot apocalypse? And how can you prepare yourself for the robot apocalypse? So let's start with that first question. What's the current state of the robot apocalypse? So in terms of AI and automation, there's various frameworks, but we're going to focus mainly on machine learning, sort of one of the main tenets of AI. And there's a basic framework for machine learning. You have 3 distinct stages. You have data, model, action. So each of these stages, so the data, so raw information provided to a machine learning system. The machine selects an algorithm to identify patterns in the data. And you've got different types of data. 2 that I think would be relevant to technical writers: training data. So sample data to provide to a machine learning system to get it to train itself on what patterns to identify. And then testing data. After you've trained it sufficiently, what data to provide to make sure that it produces the right outcome. A model, so patterns developed from the data. And humans can provide those models as well, and machine learning can develop new models as well. And then finally, actions, so the resulting task that the machine performs based on the decision from the analysis of the data and the models. And in supervised machine learning, we can approve or disapprove the resulting action, and then our approval and disapproval factors back into the machine learning model. So for example, if a machine learning system presents you with something that you don't like, you can say no and goes back to the drawing board. Come up with a new analysis and provide a new action that you can approve or disapprove. So let's use a simple example. If it looks like a duck. So we have a robot there. Based on the 500 ducks that you showed me, I can confirm that's a duck. Good robot. But wait, we've got a new bit of data there. So looks kind of like a duck, and based upon what I interpret, it seems like it's 80%. It has 80% of, say, the features of a duck. So I'm going to call it a duck. Uh-oh. What was that noise? Well, okay, some new data and some model modification. Ducks go quack, geese go honk. But geese do look similar to ducks. Ah, so that's a goose. Good robot. Now that sounds like a goose, but it doesn't look like a goose. And it definitely doesn't look like a duck. It looks like a Ford Fiesta. Good robot. Now let's use some real-world examples. In terms of technical writing, I mean, there's been some advancements in content generation. So for example, Google Smart Compose, and its ability, you probably have seen this before when composing an email. It predicts the next word as you're writing an email. And you can see the paper that's based on there. I've got the link down the bottom there. Monzo, a bank, is using AI-assisted help based upon the context of a user throughout its interface. So if you go through a particular context, then request help, it can track exactly based upon previous searches, so previous user's navigation through its user interface. It can provide you with the same sort of help or direction that you might be looking for. Do not pay. This is a big one here. So my wife is a lawyer, and we discussed sort of, I guess, the implications of this in her profession in terms of will lawyers be eventually replaced by AI. So if you don't know about Do Not Pay, essentially it's a machine learning system that helps people dispute parking tickets and also other legal aspects as well. It helps them navigate through certain legal aspects. So as the website implies, it's the world's first robot lawyer. Now we go into some of the more murky machine learning experiments. So machine learning Harry Potter. Who's ever seen this? Raise your hand. We've got a couple of people. Just to sort of read to you this story. This is a machine learning system that took all of the Harry Potter novels and then tried to write its own. The castle grounds snarled with a wave of magically magnified wind. The sky outside was a great black ceiling, which was full of blood. The only sounds drifting from Hagrid's hut were the disdainful shrieks of his own furniture. Magic. It was something that Harry Potter thought was very good. Leathery sheets of rain lashed at Harry's ghost as he walked across the grounds toward the castle. Ron was standing there and doing a kind of frenzied tap dance. He saw Harry and immediately began to eat Hermione's family. Ron's Ron shirt was just as bad as Ron himself. If you two can't clump happily, I'm going to get aggressive, confessed the reasonable Hermione. Hilarious, but gibberish. Now just imagine though, if you were a customer and received technical documentation written in this style, you would demand a refund. I mean, this reads like J.K. Rowling had a concussion and wrote her next book. It's quite scary, actually, when you think about it. But I mean, it's sort of an example of sort of like showing how machine learning, can be used to generate some content there. There are advances that sort of need to be made. But then we get to the dark side of AI and machine learning. So fraudsters use AI to mimic CEO's voice in an unusual cybercrime case. So basically they're able to use artificial intelligence to replicate the voice of a CEO, and I think it was £220,000 to be able to transfer from the CEO's account. So that's quite scary there, sort of like if we're sort of venturing into what AI can do and sort of, I guess, our relationship with it as well. So I sort of provide that there as sort of an example of how it can be sort of used for the wrong purpose. Now, what opportunities are there for technical writers in the robot apocalypse? So before we answer that, let's consider what a technical writer is good at. So for a start, we're good at researching topics by looking at existing information, by consulting with subject matter experts, and also our experience when using the product itself. We're also good at developing user stories and developing information architecture, as previous session demonstrated that Nicola ran, and then developing content. We're also good at verifying the quality of the content, so looking at style, looking at QE testing, looking at the user experience, before we decide to press the button and publish. Now this is actually quite familiar because this fits within the same machine learning paradigm that we had before. You've got your data, model, and action. And there's a bit of a parallel between what technical writers do and the sort of things that an AI are requiring. So AIs require data. They require testing data. They require training data. And this is information that technical writers can provide. We're great at research. We can provide this sort of information to an artificial intelligence system, to a machine learning system. And we can also develop test data to verify that the AI is actually working. We're good at developing information architecture and user stories. We can develop models for the data as well, for the AI to be able to produce a meaningful result. And then action, we can supervise and improve the resulting decision. We can say, yep, that's great, publish. We can go, nope, back to the drawing board. And I think actually probably the most important part of that is the data. Because one quote when researching for this talk, I read a quote that I found on numerous people's blogs, on numerous articles: a machine learning model is only as good as the data it is fed. And I think that this Twitter post encapsulates that very well. If all your friends jumped off a bridge, would you follow them? Machine learning algorithm? Yeah. I should actually expand upon that as well. If you sort of think about that, I know that's sort of meant as a joke, but if you apply the same logic to an AI that's running air traffic control, that can be quite terrifying. As technical writers, how can you prepare yourself for the robot apocalypse? There's a couple of things you can do. First of all, you can embrace it. Just like that image I showed at the start of Bender and Fry hugging it out. Embrace it. Don't be afraid of it. Learn how AI and automation works and develop your skill set. That's probably the best thing to sort of avoid fear of something, is to learn more about it. And then probably most importantly, start identifying opportunities to adapt your documentation with automated procedures. To give you an idea from my own personal experience, I learned how to use Ansible. And what I started with just a training course, and then I sort of tried practical examples just in my own personal use. But then there came a time, and I'll get into this use case a bit later, where I found a practical use within a documentation context for Ansible in terms of adapting what was in the docs into an Ansible playbook, and it turned out quite well in terms of what I produced. And as a result of that, I'm currently developing what I call a documentation augmentation initiative at Red Hat. So what is documentation augmentation? So what it does is essentially adds an automation option on top of step-by-step instructions. So you have procedural content, you have an option for users to, instead of following the manual procedure, to use a playbook or a script or something along those lines, some form of automation there. And it helps, as I've said here, to complete the task quickly and efficiently, which ultimately improves upon the user experience. Why did I pick the word augmentation? Because both procedural documentation, augmentation, offer value to the end user. Detailed procedures as well as concepts, reference material, provide context and motivation, and some customers prefer to follow manual steps. So automation provides efficiency and repeatability, but it doesn't replace procedures. It merely just augments them. It provides an additional option there. Why use Ansible playbooks for augmenting documentation? First of all, they're easy to use and easy to read as well. They're YAML-based, and following it can be quite simple, and sort of it follows a step-by-step process. The tasks also map to steps as well. So like documentation, Ansible playbooks contain tasks and run steps within order. The difference is that instead of the user running the steps manually, Ansible runs the steps. This sort of goes back to what I was talking about before in writing docs for robots. Modules also replicate functions. So Ansible modules provide opportunities operations to perform at each step. So instead of the user performing an operation manually, Ansible uses the module to perform the operation. Independency and variability, I'm having trouble with my English. But you can run a playbook multiple times on its own and you receive the same result, but you can also provide a certain amount of variable data to a playbook, and it will customize the actions based upon what you want the result to be. Can reduce human error as well. So users can make mistakes when following manual steps. They might miss a step. They might incorrectly type in a command. With an Ansible playbook, it just runs end to end. There's no onus on the user. And unit testing. Ansible playbooks can also be used to test functionality and continuous integration of procedures. And seeing that you're augmenting procedures, they act as a good unit test to the manual procedures as well. To give you a basic example of how documentation can map to an Ansible playbook, this is just a basic example of creating a user and providing sudo access. So the manual steps. Step 1, log into your system. Step 2, create the user. Step 3, create the sudoers file. 4, edit the file, add your permissions. And then 5, set permissions on the file to read only. Very simple procedure. But instead of running it manually, we can run it as a playbook. So we've got a playbook there and a template for what's to go in the sudoers file. And as you can see here, I've mapped the playbook to each individual step. So step 1, log into your system as the root user. So I've got here the step 1 here, signifying that I want the root user to run the tasks within this playbook. The tasks, first of all, create user. I'm using the user module to create that user. And then step 3, 4, and 5 are part of the template module, where I'm creating the sudoers file, setting permissions, and providing content from the template that I specified before. In addition to this, you can also provide a set of variable input into the playbook as well. So I could specify, instead of a fixed variable I had before my login name, I've got a variable there called myUser, and I can use this in various places to create a custom user. So if I want to, I could have it Ben Long instead. So my own use cases here. So these are some of the examples that I've been working on. So the first thing that I did was a proof of concept using some documentation I'd written for OpenStack to back up and restore the control plane. Who here has had any experience with OpenStack or knows a bit about OpenStack? A couple of people. So for people who don't know, OpenStack is a cloud infrastructure project. Red Hat offer their version of OpenStack, OpenStack platform. And it can be quite a complicated system because you're dealing with multiple services on multiple nodes. So it can be quite hard to manage there. And so backing up and restoring can be quite difficult in that respect. And especially in this context, I created a procedure to be able to do it in a high availability environment as well. And the resulting documentation was quite massive. Like I think it was a 30 or 40 step procedure. There were sort of little things that you had to sort of watch for. So I adapted this documentation into an Ansible playbook because the user experience of the step-by-step process, it just introduced so much opportunity for error, so many missing commands that you could put, so have a single playbook to run. And yeah, it reduced that manual process from taking several hours to perform the backup and restore option to just minutes. The backup actually, I think, took 30 seconds to run the backup playbook, and I think about 4 or 5 minutes to run the restore playbook. And this is sort of going from a process that took probably about, I want to say, I think it spanned probably about 3 or 4 hours. So to have that reduction in time there is quite significant. As I mentioned before, it's less error prone because you've got your playbook, it's been tested, there's less opportunity for error there, and we can use it as a model for continuous integration unit tests. We can customize it with variable data, so we can provide different data for different systems. So for example, if there's only, say, a subset of services that we want to back up, we have that option there as well. One aspect that I really liked is this encouraged more collaboration with my engineering team as well. I ended up developing these playbooks in the upstream as well. And I felt more connected to the engineering team as well, and they felt more connected to me. And excuse me. We're able to find opportunities to improve not just the documentation, but the general user experience of the process as well. And I've actually got a full presentation on this topic as well for the Open Infrastructure Summit in Berlin 2008 there. So I've got a link there if you want to check that out and see examples. And also a live demo of it working as well. And what I'm currently doing as part of the documentation augmentation initiative is developing Ansible playbooks and a role based around a guide that I wrote, Director Installation and Usage, which is a guide that shows how to install the main administration component and also how to use it to deploy your cloud. And so far, it works really well. I've been able to get it to run so that it installs Director and carries out the main initialization tasks, and then to sort of move on from there and to develop Ansible playbooks from the rest of the guide as well. And I've seen other examples internally of Red Hatters creating their own playbooks, and I sort of want to bring it all together to be able to create this one set of playbooks, or this one role, Ansible role, to rule them all. So you can use it for testing documentation, to use it for CI integration, continuous integration and continuous delivery, to use it for QE testing, and also, most importantly, to provide it to the end user so that using this is just easy. You just run the playbook, let Ansible take care of it. Some final considerations as well. So having said all this, there are traditional documentation opportunities outside of automation and AI. For example, conceptual information. We need to be able to explain a new concept to people. And I don't think that artificial intelligence is able to do that just yet. Because a lot of the machine learning models are based on data that already exists. If you have a new concept that's just been devised and you have to explain it, machine learning model can't really do that because it has no prior basis to use for generating that concept. So it's really up to us as technical writers to be able to deliver that conceptual information. I mentioned that with automation, it's probably best to sort of let them focus on the actual task rather than doing the documentation. However, there are certain circumstances where automation is great for documentation. For example, generating reference material, API documentation, parameter listings. So documentation within the actual code itself and being able to produce that. So being able to generate documentation from the code. And I also think that we should still write traditional documentation anyway, just as a backup in case things go wrong. I mean, as good as an AI is, things can go wrong, and we might need to know how to reset to factory default. That's a good question. We need a guide on how to run the laser to shoot the robot, put it out of its misery. We wouldn't do that to the robot. But that concludes my presentation. Are there any questions? Lucas.
Yep, one question over here.
Hello, Dan.
Hello.
Some disclosure, Dan used to be my manager, so this might play into my my question. But
I get it now.
You mentioned having this augmented documentation about having like these scripts, these Ansible playbooks that you have to help users. I'm wondering what your thoughts are on when we get to that kind of level, and it's always a battle between like what should be in the product versus what should actually be documented. Is that, do you think with this kind of thing that you're actually letting the product off a bit easy in terms of like that kind of thing should actually be in the product itself to make users' life easier rather than you sort of having to do it as a playbook?
Quite possibly. I mean, as I said at the beginning, I kind of consider that as writing docs for robots. Now, in terms of the distinction between, okay, what's development, what's engineering's responsibility, what's technical writing, what's technical writer's responsibility, I kind of see those lines being blurred more and more as we're sort of going into the future, and I think that that's just a part of how the role is changing. And I do think that we need to focus more on those aspects as well. Yeah. Did that answer your question, or? Okay. Well, what didn't it answer?
Like us as documenters covering up for product shortcomings in terms of the user experience.
Yeah, I mean, that's probably a good point in terms of the product shortcomings. But I mean, I think that we do have, and not just technical writers alone, but everybody who works on a product or a project has an obligation to identify shortcomings and to sort of say, yep, that can be improved. Now, I think in a lot of cases, a lot of that can happen in the product itself. I think that sometimes it's a case of you write a documentation that sort of acts as a bit of a band-aid, not for all situations, but for certain situations where it's sort of like there's an expectation, sort of like where there's this shortcoming. Can we write some docs to sort of show how to work around this issue? When really we can automate, say, a particular function and sort of like, yep, let's make this a bit easier instead of having customers have to, navigate through all these different, I guess, well, to navigate through a minefield, basically, to try and just sort of, wipe all their way and just sort of say, yep, run this, you'll be fine. So, yeah, does that sort of address the shortcomings? Okay, cool. Whew. Any other questions?
Yep, questions?
If not, just one final thing to say. This is the last presentation of the day, and I just want to give a shout out to Joe. He's been probably the main contributor, or the main coordinator for this. I've sort of been assisting in some regard, so I just want to call out Joe.
You've done a lot, Dan. You've done plenty.
You've done way more, but could everybody give Joe a round of applause?
Thank you. It's really the audience and the community who showed enough focus and paid attention to the sessions that we had today and showed an interest in documentation who also should be thanked. So give yourselves a round of applause for coming to see our mini-conf today. Thank you. And thank you, Dan, for advice and helping me put this together. And even though they're not here, Brian Moss and Lana Bridley deserve thanks as well for their good advice on setting this up today. And to our room monitor, Hugh, thank you very much for all your hard work, and our wonderful AV team, Craig and Mike, for putting up with me forgetting to give them cues and recording our sessions today and helping us out with adapting micro USB to HDMI and various other formats that will appear throughout the day. So thank you very much to you all as well.